Hi, welcome to our Lab 3 walkthrough. I'm re-recording this with Iva as my helper while she eats her snack. Hi.
Hi.
Okay. And so this lab actually has the data set that you already have. So all you need to download is your Lab 3 Markdown file into your same folder with all your other labs. And if you don't have the Loans 50 folder, you'll need to download that. But otherwise, we can just get started with Lab 3. Here we are plotting numerical data. And so that's the new objective is we're learning to analyze and display numerical data. So we're going to look particularly at variables within Loans 50 that have a number. Looks like I have a bunch of data variables here from previous projects. So I should clear this all. And now you can just see what I'm seeing here. What was that? Okay. So I run Loans 50, and if it runs green, that means you have it in the right folder. If not, make sure you have put it in the same folder. So I already have. So as I was saying, Loans 50 has a lot of variables. We're going to start plotting variables that are numerical here. So the first thing we can do is look at the data in a variable. So insert a new code chunk, and we'll say loans $ interest rate. And you notice it auto-populates with the variable that matches what I'm typing. So we can just click on that. And if we hit Control Enter or Command Enter for an apple, it will do the same thing as hitting play here. And it shows us these are all the interest rates for 50 loans, 10.9%, all the way down to 6.08%. So that's a lot of information. It doesn't tell me very much. I could get a very good summary of the data by saying what the mean is. So I say means, loans, $. I want the mean of all this information here. So basically I say the mean of my interest rate variable. That would give me the mean. And then I could do the same thing for variance. var loans $interest rate. That's the variance. The standard deviation would be, oh, notice this. If you ever notice your arrow goes away, it can sometimes happen because we start typing things outside of the code chunk. So I actually have to put my code on the next line. Right. Right. Okay. So that's our mean, variance, and standard deviation. This tells us about the average. Excuse you, Eva. There's an average rate of 11%, and we know that the standard deviation is 5. That says roughly 68% of our loan interest rates fall within 5 percentage points of our 11. So that's just one thing the standard deviation tells us, but we'll get into that more later. So that's useful. That's good. But even better would be some kind of picture to describe this data. So we'll talk about several different kinds of plots. Talk about histograms and box plots are very concise ways of describing a numerical variable. So if I ask you to plot a one-dimensional numerical variable, these are the two plots that we'll consider. So here's how we plot a histogram, and you'll see what a histogram is just from looking at this. You'll see we plotted the loans interest rate variable using our hist function, and then we said what the X label was. The title is the main, the call is orange, and these are always separated by commas, comma, 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 until we get to the close parentheses. And you'll notice this close parentheses, when I put my cursor on it, it highlights this open parentheses so we can see there's a correspondence. So this is a good graph. What this tells us is that between 5 and 10%, there are about 26 loans. The frequency is the number of loans. Between 10 and 15%, there's looks like 13, 15 to 20. So it tells us that the lower loans are more common, and as we go up to like 25% to 30, that's the least common. So what I just said, you can summarize, part of which would say 5 to 10% interest rates most common. Can we pause it, Iva? Let's pause it. We had to get some more strawberries. Okay, so this tells us the 5% interest rates are the most common, and the least common is higher interest rates. All right, so that's what that histogram tells us. It summarizes a lot of information in a little bit of space. So your next task is to make a histogram of the annual income variable. So when we're starting to make plots, best advice I have is careful use of copy paste. So I'm going to copy paste this whole code chunk from the beginning to the end. If I copy just part of the code chunk without the beginning and the end, it won't run right, or at least the arrow won't show up there. So it's just particular like that. So to make my annual income variable, I will say instead of loans $ interest rate, I'll say loans $ annual income. And if it doesn't pop up, maybe you can retype for it to auto-populate. And then instead of interest rate, I'll say annual income. It looks like I can't spell histogram. Histogram. Histogram of annual income. Can you say histogram, Iva?
Histogram.
Histogram. There you go. So let's see if that runs now. And I'll make it blue. I think income should be blue.
Yeah.
Okay. Pretty. Oh, wow. Look what that tells us. It tells us where the spread of income is. Most people make between 50 and 100,000. And very few people make a lot of money. And then a good amount of people make between 0 and 50. Cool. So that's a histogram. Very useful. The next plot for numeric variables is box plot. And here's the same bit of code from before, but instead of hist, I said box plot. You could say x equals, although you don't have to. If you, whatever the first thing you put here, it thinks that's your data. So here's a box plot. I don't like this as much. This tells the spread of my data. I don't like this as much. What I like is saying horizontal equals true, so I can just get a better view of it. I'm gonna get my pen out here to describe what's going on with this box plot. So annotate with red. Okay, every time we have a box plot, there's going to be a middle line, which takes the median. That's the middle data point. If you were to line up all the data from left to right. Okay, now at either end of the box, go away. Either end of the box are what are called quartiles. This is the first quartile. This is the third quartile. What does that mean? The first quartile means this is the 25th. I'll say it this way. Undo. This means 1/4 of the data falls below this point. Yeah. So 1/4 of the data falls here. The third quartile says where 3/4 of the data falls below. So you see 3 quartile referring to a quarter. Below, that's pretty cool. So 3/4 of the data will fall below that point. And then anything that's above that, we're going to extend. Okay, so this distance right here, I'm going to use a different color here. Another really important part of this graph is the length of this box is called the interquartile range, IQR, interquartile range. It's between the two quartiles. You see interquartile. So that interquartile range is used to decide how far do I go out to my whisker. This is called a whisker here. And the whisker always extends 1.5 times the IQR. If there's data beyond that. So any data beyond that is a potential outlier. Okay. Now, if there is no data beyond that, such as this case here, where it only goes a little bit and stops, that means that's just my minimum data point. So if the data does not extend 1.5 the IQR, then we just go to the minimum quartile, the minimum data point, and we stop. So looks like 5.1 is the lowest interest rate and about 6% is the maximum interest rate. So there's a lot of information compacted into a box plot. Very useful. So that's a question that I'll ask, like, hey, what is the middle 50%? If 25% falls below this point, 25% falls above, the middle 50% is this box right here. So about from 8% to about 14% is where the most of the data lies. Okay. So that's a visual of what our box plot tells us. So this tells us there's two potential outliers because these 2 points here extend beyond the box plot, beyond the whiskers of the box plot. So now to do the same thing, let's do an annual income box plot. So I'm just going to copy all this. I like the horizontal box plot the best, so I'm going to use that. And instead of interest rate, loans $, annual income. And so I got to change my label here. Annual income. Actually, I think income should be green. And I plot that. And ooh, that tells me how many, the middle range of my income is from roughly 55 up to 100. And here are potential outliers. So that's our one-dimensional data. And let's go on to two. Two-dimensional data is used, the main representation of two-dimensional numerical data is what's called a scatter plot. And a scatter plot in R is made with plot. So to run this, there's lots of different points. Each point corresponds to a loan where the interest rate for that loan is looks like 60% here. I'll draw this. 66% is this loan. The income of that loan is, looks like about 5K, 5,000. So lots of different loans. And shows a trend if there happens to be one. So I think you've probably seen this kind of plot before. It's like your XY points on just a graph from geometry or algebra. So from this, I would say it doesn't really appear to be a trend. If there's a trend between the 2 points, if you can see there's a line, you would say there's an association, and this is kind of subjective, but to my viewing, I would say no, there does not appear no association. And later on, we'll get to ways of measuring what that certainty of association would be. But for now, we're just practicing plotting graphs. So in your textbook, also in the lab, we have, for this lab 3, there's a graph I want you to try to recreate. It looks like it has income on the x-axis and loan amount on the y-axis. So we have to go back to our code here, copy paste this, and put in the correct variables for x and y to make a graph that matches this. So see if you can figure that out. And then your last task is to make your own scatter plot with any 2 other numeric variables of your choice. And tell me, does there appear to be an association? So once you figure that out, you can get to work on the online questions in this lab. So I hope that helps.